The total mass of a man and his bicycle is 80 kg. He started at the bottom of a slope with a speed of 6 meters per second and then freewheel up the slope. The angle of the slope to the horizontal is theta, where sine theta is equal to 1/40, and frictional resistance is 38 Newton. How far can he travel up the hill before coming to a slope, to a stop? Before coming to a stop. Now this is the diagram. So now let me assume the whole weight, the total weight is like a box. Now let's draw the free body diagram of this structure. This is the weight is 80 times acceleration due to gravity. Now you have here is theta, because here is theta. So the reason why this place is theta is now here is 90. Here should be 90 minus theta, and the whole of here is 90. So if you say 90 minus plus theta will not give you, here will be theta. So that is why there is theta. So now to resolve the resolution of this force, this weight, you now have this force. You have a force like this in this direction. You also have the one in this direction. So the resolution of this weight, which is 80 gram, here you have theta here, will now be equal to, let me say this is the y and this is the x of it. So now with that force, let me say f subscript y, f subscript x. Now if you want to resolve this weight now, which is 80 gram, you will now have the f subscript x all over 80 is the same thing as sine theta, because the f subscript x is the opposite of the angle and 80 is the hypotenuse. So why f subscript y all over 80 is cos theta. This now implies that f subscript x is equal to 80 sin theta, and f subscript y, which is the same thing as is equal to 80 cos theta. Now you will have normal reaction from this, from the surface, which is n. Now we have frictional force. So the object is moving up the hill. Now, so the frictional force will be acting downward. So this f subscript x, which is 80 sine theta, is acting downwards too. then this frictional force, which is mu times n. Now from the equation, mu times n, which is the resistance or the frictional resistance, is given as 38 Newton. So we don't need this again. We can substitute it in the equation. So now let's look at the acceleration. What will now be the acceleration? How can we get the acceleration of that the object we use to move a distance before stopping? As it's moving and it is being pulled down by these resistance forces, so it means that it is decelerating. Those forces are not aiding it to accelerate. So it's decelerating because the forces are acting opposite to the direction. So now that means, let's say that I have a local, okay, let me say the coordinates here. You have x here and you have y. Now the forces along the y-axis, the sum of the forces along the y-axis is equal to 0 because there is no vertical, there is no motion along the y-axis. So the acceleration along the y-axis is equal to 0. So now, since the mass times the acceleration, and since the acceleration along the y-axis is 0, then the whole of this is equal to 0. So now if you sum the forces, you have, although this equation is not needed in this problem, is not needed in this problem. What is needed is the summation of the forces along the x-axis is equal to the mass of the object times the acceleration. So now we're looking for the acceleration of this object. If we're looking for the acceleration of this object, now let's sum the forces. The forces is acting opposite in the direction of the flow. So now you have minus 80 sine theta, which is acting downwards, along the plane, and you have the resistance, which is minus 38, which is equal to ma, and m is 80 kilogram times the acceleration. Now, and you have sine theta as the same thing as 1/40. Now substituting sine theta equal to 1/40 into this equation, you have minus 80 1/40 minus 38 equal to 80 times acceleration. So now minus 80 times 1/40 will give you minus 2 minus 38 is equal to 80a. Now we now have 80a equal to minus 40. So a is the same thing as minus 1/2 as the acceleration. So meter per second square. Now we have gotten the acceleration. Now we are asked to get the velocity, that is the distance the man will travel before coming to a stop. Now, so we're asked to calculate the distance, and now let's say is a linear motion and is decelerating, so it will be this form. This is the velocity This is time. Let's say in seconds. Now, at this point, this is initial velocity u, and this is the final velocity v. Now, from here to here, this is the duration of the t is the duration of the travel. Now, to get the distance, it will be the area of this shaded portion, and the formula for the area of this shaded portion, like this is a trapezium. So for a trapezium, you use the area of a trapezium to find the distance that the body will travel. So now the distance, which is x, will now be equal to half the velocity, the average velocity, times the time, which is like the height here. You know, the area of a trapezium is half, bracket open, the sum of the parallel sides, which is v plus u, times the height, which is t. So that is the same thing here. So in general, let's say it comes to the realization that it is the average velocity times the time. Now, from this graph also, there is a slope here. There is a slope, and the slope is a deceleration. The slope of this uniform motion should now be, is negative, so it will be u minus v all over t, which is a negative value, which I can change in this form, and now put a negative here, meaning it has a negative value, because it is decelerating. When you look at the graph, you see that there is a decrease in the velocity. So now let me now input this. Let me now solve for t. This now implies that minus at is equal to v u. So t is equal to v minus u all over minus a. But I might decide to call now v minus u all over d deceleration, because minus acceleration is deceleration. So I will change it to v minus u all over d, which is deceleration. Now let me substitute that into equation. Let me call this equation 1 and call this equation 2. Let me substitute equation 2 into equation 1. I have s equal to half into v plus u times v minus u all over d, which will give us v square minus u square all over 2d. Now at the point, let's give the conditions. So at the initial speed, it is 6 meters per second. Now at the final speed, where it stops, is 0 meter per second. Sorry. now is 0. And again, the d is minus half meter per second square. So substituting this into the equation, we now get our speed. We will now get our distance, sorry. So now the v square minus u square all over 2d. Now the v is 0 minus 6 square all over 2 times minus 1 over 2. This will give us minus 36 all over minus 1, which is the same thing as 36 meter. So this is the answer. So this is the final answer. The distance further it will go is 36 meter. Further it will go is 36 meter. So thank you for watching. Have a nice day. If you like the video, please subscribe to my channel and hit the notification bell, and also do well to share the video. Thank you.